Okay, let's start our session then. Hello everyone, and welcome to today's session, which is session number 7. And I hope you all are enjoying the session so far. And I hope you all are fine and healthy. Thank you so much for everyone who completed and submitted their assignments, because that then informs me that yes, you are understanding whatever we have been discussing in the previous sessions. So just to recap, so in last session, we were still continuing our test levels, and in test levels, we completed integration testing. If we see the entire test levels, then we have done component testing, we have covered integration testing, and in today's session, we will be covering system testing. So we'll start with the definition of system testing. System testing focuses on the behavior of a whole system or product. So as we are going up the test level pyramid, we need to also start thinking that how each test level is different from the previous test levels which we have already covered. So we already did component testing and integration testing. In component testing, we covered that it is the testing in which individual components or modules are tested separately. And then in integration testing, we are testing the interaction between two or more modules or components or systems. And now coming to system testing, by this point, we are assuming that everything has been completed in terms of components, and they are being integrated as well. And now we have a whole system. So the focus of system testing level would be that we need to make sure that the whole system or product is working as expected. And this is the level where mostly testers do their test execution. So let's just see a few important points about system testing. All components are integrated to verify if the system works as expected. So yes, at this level, all the components are fully built and they are integrated. And then we are verifying that the system as a whole is working as expected. Second is performed on test environment. So if we see the previous test levels, component testing is usually done by developers, and they are doing their testing on their local machines. They don't need a specific environment for that. So they are building one component and they are testing, and everything is done in their local machine. The same is with integrated as well, that as the components are being built, they are being if we are doing continuous integration, we are deploying everything in the shared repository. So we are just copying and moving everything to the shared repository, but still all the development is being done on the local machines itself. We don't need a dedicated environment for that. When it comes to system testing level, now this is the environment which is quite close to the production, which means that now in our SDLC, we are coming very close to that time where after system testing and the last one acceptance testing, then the next step is production, then we are ready to release. So at this point, it's very important that we have a dedicated test environment where testers are testing, and it should be quite similar to the production environment. So it should mimic the production environment so that we can make sure we are confident that whatever we are testing on that test environment, the product or the project will work the same way in production as well. So we will cover this point a bit more later as well. The third one is, in some cases, automated system regression tests provide confidence that changes have not broken existing features. So if we are doing let's say agile methodology or even sequential as well, where there are a lot of regression tests added, then if we do automated testing, then it saves us a lot of time, and it keeps us giving the continuous confidence that whatever we are building is working well. So let's say in agile, if we are adding new features in the system every sprint, then of course we have to make sure that those new changes hasn't caused any bad effect on the system or on the features which we have already tested in earlier sprints. So that's why we do regression testing at the end of each sprint, each cycle. And if we automate those regression tests, then it makes life easier, because then we can focus more on the functional testing of system testing of that sprint, and regression testing can be automated. System testing often produces information that is used by stakeholders to make release decisions. So now this is the testing after which test reports are generated. And the test execution done by testers, the test reports are shared by stakeholders, because based on the test reports and the level of quality of that product, the decisions are being made that whether we are ready to release this product or project to live or not. So that's why system testing is also important for stakeholders as well. System testing may also satisfy legal or regulatory requirements or standards. So just like integration, in integration testing as well, we had this aspect of legal or regulatory requirements or standards. The same is for system testing as well. If we have a specific product or a specific project where we need to comply with some industry standards, then that needs to be taken care of as well during system testing. Next, I would like to take an example so that we are able to understand system testing in a better way. So over here, of course, we are not taking the entire system because in the entire system, there will be numerous requirements. I'm just taking one requirement right now. And let's say that we are taking a requirement for a login page. So it can be a generic login page. We are not talking about any specific system. Let's just consider that there is a login page, and these are the requirements given to us. The requirements are: users should be able to log in using valid username and password. Submit button should be enabled when username and password are entered. User should navigate to my account after successful login. So over here, we have got these requirements for the login page. Developers will take these requirements and develop login page. And then testers will use these requirements as well to design their testing and write their test cases as well. Okay, now we'll take this requirement as our base, and then I would like to go through all the test levels we have covered so far so that we can understand that how at each level this requirement was interpreted. Okay, so let's say this is our login page. This is the UI of our login page. And then there's another page of which is my account. So right now we have two components over here, login page and my account. These are two components. These will be tested, built, of course, separately. And let's say that now we are at component testing level. This is the level where a developer is building this page based on the requirements and also per their discussion with the business analyst or maybe the project manager. And based on that, these are the things which a developer is taking care of during component testing. So which is username is a text field which accepts alphanumeric characters. Length of username field is 50 characters. Password is a text field password field is encrypted. Now over here, if you see the requirements, how many characters should be there, etc. This is not defined in the requirements, because most of the time the requirements doesn't go in that much detail, especially if it's like using agile methodology, because their high level requirements are given, and then there's a dependency that the team is working closely together and they are talking to each other, asking questions, and then based on that, the project is built and tested. So over here, of course, when a developer is developing this, then maybe the prototype is already given to them that yes, it will be text field. It's obvious that username, if we have to enter something, then it has to be either a text field or a drop down. Mostly it's text field. And if maybe they have spoken to the requirement people that how many characters should be acceptable, and they have agreed on 50. So, and of course, this is something which the developer needs to be include in their code as well. So they need all these details. Then password, of course, this is quite common that password should be encrypted because everyone shouldn't be able to see the password. Then length of password field is 50 characters. Submit button should be enabled when username and password are entered. So when a developer is doing component testing, he or she is testing these things, making sure that the functionality of this component is working as expected. So these are, there might be like few others as well, but these are like the main ones which we will be considering that a developer is taking care of during component testing. And the same would be for my account as well, that my account, whatever the functionalities needs to be there in the my account page, then those will be also tested individually. So in component testing, we have tested login page and my account page. It's passed, component testing has been passed. And now the developer has said that login page and my account, these two components are ready to be integrated. Next step is integration testing. Now we are on the second level. In this level, now what we will do, that already login page functionality and my account functionality has been separately tested. The functionality separately tested. Now we are integrating. So in integrating, we'll take care of this requirement that user should navigate to my account page when valid username and password are entered and submit button is clicked. So over here, now we are talking about the communication between these two pages, that yes, if valid username and password are entered and submit button is clicked, then what will happen? What should happen next? It should navigate to my account page. So now this is integration testing, that we are integrating these two components. So I hope this part is clear as well. So now if you can see that we have covered a lot of functional testing during component testing. And then we have also checked the integration as well. Then the question is that why do we even need system testing? If most of the functionality can be tested earlier and then the communication also tested over here, then why we need system testing? Let's see that. Now in system testing, how a tester will test and what other things or what value a tester can bring in system testing. So the same requirements which we discussed earlier, which were given, based on that, a tester will come up with some test cases. So over here, I have covered few of them. These are by no means the entire test cases, but like few of them I've given. So in system testing, a tester will test that user should be able to log in when valid username and password are entered. Then after clicking submit button, user is navigated to my account page. Username field is accepting 50 alphanumeric characters. Password field is accepting 50 characters. So these are like few basic tests, the positive test, which a tester will be testing. So let's say all of these are passed. These tests are passed. And these are the tests which a developer also covered earlier during their component testing. So hopefully there shouldn't be any errors over here in this functionality. If there is any issue, then it might be that something was not covered properly in component testing, or maybe it can be due to the change in the test data, which is used over here, or the test environment as well, because a developer did component testing in his or her local environment. But now we are testing this in a dedicated test environment. So might be what was working on a developer's local environment, local machine, now it's breaking on the test environment. So that's why it's important that we have to test all these functionalities again in system testing, even though they were covered in component testing. Now the other ones, these ones which I've highlighted, these are the ones which were not covered during component testing, but a tester need to come up with these kind of test scenarios as well, because a tester is testing and or seeing the application from a user's perspective. So a tester will also test username field is not accepting special characters. As we have got this this agreement that there should be 50 alphanumeric characters, so a tester will always put some special characters to see that okay, how the functionality behaves if I put some special characters. Yes, it shouldn't be allowed. Then the next would be user is not able to log in when invalid username or password is entered. In component testing, a developer has tested that enter valid username and password and the user should be able to log in. But what about if they are invalid? So these kind of combinations test will be done by a tester during system testing. Then the next is username and password fields are mandatory. If we can't just leave username or password field empty, so it has to be mandatory. Usually there are some asterisks as well in few fields where they are mandatory. So maybe a tester can point out that yeah, a user should be informed of that yeah, this is mandatory or no. But login page, of course, we need both fields in order to log in. That's pretty obvious. After 3 unsuccessful attempts, user account should be locked. So we have to come up with a limit that from security perspective, that after how many unsuccessful attempts, a user should be locked, and then they have to reset their password, or maybe they need to talk to someone in admin based on what kind of product they are trying to log in. So let's say that they were the 3 unsuccessful attempts is the requirement which was agreed by talking to the business analyst. User should be able to reset password using forgot password link. So now this is a scenario a tester came up with that, okay, fine, I'm entering all the details, but what about if I forgot my password or my username and I want to reset? And over here, tester can't see that forgot password link. So this would be a bug. And this would be a bug in in the requirements, because ideally this should have been covered in the requirements and a developer should have developed it. Developer didn't develop it because it was not mentioned in the requirements, and at that time maybe no one thought of it, or maybe when the requirements were being written or finalized, tester was not part of this activity. This is the reason why we emphasize that a tester should be part of the early phases as well. And that's why early testing is recommended, because just imagine in this phase, if the tester was also part of the requirement activities, then a tester would have spotted that scenario right over here. Okay, that what will happen if a user forgot his password and they want to retrieve their password? What will happen? Then the requirement would have been entered over here, and the developer would have developed and tested as part of component. But that didn't happen. It crossed component testing, it crossed integration testing, and it was identified in system testing. And we also know that as late as we found the bug in the SDLC cycle, it's expensive to fix and get this done, because now what will happen again, there will be changes done in the requirements. A developer will build that. Again, developer has to do component testing, then integration testing, and then it will come again to system testing. So it has wasted a lot of time of many resources, and this can affect the project timeline as well. Okay, so these are some high-level scenarios, both positive and negative, of system testing. So apart from the test cases which I have mentioned, can you come up with some other test cases as well, which I haven't mentioned yet? What else you can think of as a tester? What else you will test for the login page? Let me know your comments in Q&A section. Think about the scenarios which I haven't covered. Okay, Denmark has mentioned successful message on or error message. Absolutely, that's right. So let's say that if there was an error message that the username or password is invalid, we need to inform the user as well. Otherwise, what will happen? That yes, username, password we are entering wrong, we are submitting, but it's not letting us go to the My Account page. It's not logging us because something is wrong. But a user is not informed. We need to inform the user as well that yes, something is wrong, either username or password is wrong. So an error message needs to be there. Okay, Madhuri is saying color of the submit button. Yes, that's right. So we had a functionality that the submit button should be enabled, and all these we should be having a test case for that as well. Vineet has mentioned password field accepting minimum characters. Okay, yes, that's a good one that we have covered, that how many maximum characters, and we also know that the fields can't be empty, but what should be the minimum characters as well. Let's say password, we just can't have like one character. So yeah, that's a good one as well. Vineet is also saying we double click on submit button, what will happen? Okay, so if we double click on submit button, then what will happen? Yes, so these are the things which, like, sometimes it also happens that yes, we design lots of test cases, but during testing, then also at runtime also there are different scenarios which comes to our mind. Okay, let's see what happens if I do this. Sometimes there are some additional test cases which can be tested during the execution as well. Gaurav is saying email notification upon resetting of password. Exactly. Yeah. So how will we get to know that? Okay, if someone, usually if we click the forgot password link, we enter our email or username, and then we wait for an email. So yes, we need to then test that as well. And in this case, Now imagine that how big this forgot password functionality is. Just because we forgot about that in the requirement section, now itself is like a separate component, because in forgot password, we have to send an email as well. And then in the email, we have to give them another link over to come to the site again and then reset the password. And maybe that page is not even built. So now it's like it will add so much time later on in within the project life cycle, just because of that we forgot one requirement. Okay, so yeah, I hope that all this is clear now. So there are like others, and there are like numerous scenarios which we can cover in this. Like for example, we can also do some like tooltip on the username and password fields as well. When we hover, then it's gives some tooltip that yes, the username needs to be entered here, or password, and all these details. And let's say if instead of submit button, if we are just entering a username and password and we are pressing the enter key, then also submit button should be activated, and user should be logged in, because sometimes yes, it has to be the keyboard friendly as well. So these kind of things. And then yeah, if it's a web application, then we can check the login page on different browsers as well, because sometimes it works on one browser and it doesn't work on the other browser. Maybe the layout is different, or the buttons are not appearing. Maybe that button element is not compatible in a specific browser. So yes, this can be a part of system testing as well. Okay, Vineet is saying copy paste on password. Also, we will check. Exactly. Yes, that's right. Sahana is saying time taken after clicking submit button. That's a very good one, Sahana. And this is something which which I'll be covering in one of the examples later on as well. But that's absolutely correct that we have to, now this is something which comes under non-functional testing. That yes, as part of functional testing, we have tested everything, and everything is working perfectly fine. We are able to log in, but it's taking long. So this is nowhere specified, but it's obvious that it shouldn't be taking that much longer. And that's why both functional and non-functional aspects are covered during system testing, which we will cover in one of the slides later today. Right. Okay. Thank you so much for all the useful test scenarios. So seems like that it's clear. Vineet has also mentioned for system testing, product is stable or unstable. Okay, so Vineet, maybe you can elaborate a little bit more over here. When we say a product is stable or not stable, so if it's working as expected, then of course it is stable, and that's why we are doing system testing. So is that what you wanted to mention? While we wait for Vineet's response, Jatin has said, as a usability point of view, we need to verify tap sequence and cursor focus. Absolutely, exactly. We need to do that because otherwise it will not be user-friendly. So Vineet is saying we did system testing on stable product. Yeah, either stable product, or we verify the stability of a product by doing system testing. Because that's why we are doing it. Is it compulsory? So yes, we need stability of a product. It is compulsory, because that will decide that whether we can release that product to live or not, because we can't market, we can't put anything in the market which we know that it's not stable. So yeah, it has to be stable. Sahana is saying check if the UI is stable in different browsers. Exactly, yes, we need to do that because the layout can be different in different browsers. Okay, then let's move on. So just like we did for the previous test levels, we will be going through the test attributes for this test level as well. So in system testing, first of all, let's see what are our objectives. So in last session, after last session, I got one message from someone that there was something like, are these all the objectives or whatever the attributes which we discussed in the session? Do we need to make sure that everything is there in every project or product? So that's not the case. So that's why I thought that I will clarify here. Whatever we are discussing as part of all the test attributes, these are basically examples of, okay, these are the examples which can be included as objectives or as test bases or as test objects. These are by no means the entire list, or if there are 6 or 7 objectives or maybe 7 test objects, it doesn't apply to all products. It is that, yes, these are the examples for the test basis, but all of them doesn't have to be there. For example, if we talk about sequence diagrams and flow diagrams, so both of them doesn't have to be there for a project. Or in some cases, we don't even have sequence diagrams or flow diagrams. We just have requirements. Or maybe we have some only use cases, or maybe state diagrams. So we need like one of them, that should be fine. Or even if they are not there, the requirements should be sufficient as well. So it doesn't mean that we need to fulfill all of these examples. These are all examples that, yes, in objective, these are the examples which are included as objectives of system testing. So I hope that's clear as well. So let's go through the first one, reducing risk. Now, risk is something which we make sure that is part of the objective of each test level. Because ideally, if we take care of that, then as we go up the test level, then the risk will be reduced. It keeps on reducing, and we can ensure that after covering all the test levels, when we are deploying something on production, then there is a very low risk of something going wrong. That's why over here also, one of the objective is reducing risk. So though component and integration testing would have reduced the risk as well, because we have done some thorough testing of components and also an integration testing as well. But then how and why we need, like what kind of risk can be there in system testing if we have covered everything over there? So though we have already integrated and done individual testing of components, but still the risk of how all those components integrate together to form a complete system, that risk still exists. So system testing reduces this risk by making sure that the system functions as per the requirements. So that's why this is one of the key objectives of system testing. Second one mentioned over here is verifying whether the functional and non-functional behaviors of the system are as designed and specified. So we are testing both functional and non-functional. So for example, we tested by login functionality that login is working. And as Sahana mentioned, the time it takes to log in and go to the next page, my account page, that is the non-functional behavior, that how long it is taking. Is that time acceptable or not? The third one is validating that the system is complete and will work as expected. So that's one of the objective of system testing, that this is now the validation stage. We are executing our test cases over here, and we are making sure that the entire system is working as expected and it's complete. None of the component or module is missing from the system. Next is building confidence in the quality of the system as a whole. So over here, then, of course, when we are testing the entire system, it boosts our confidence that yes, the quality is high and we are satisfied to release it to production. The next one is finding defects. Yes, just like our previous test levels, we will find some defects in system testing as well. So, but of course, the type of defects we will find in this test level will be different, which we will cover in the next test attribute. And the same would be preventing defects from escaping to higher test levels of production. Now, this test level is very, very crucial because after that, either we have only one test level left, which is acceptance testing. And sometimes acceptance testing is not done everywhere. Sometimes it's only system testing and everyone is relying on system testing. And after that, it's just moved on to production straight away, depending on the type of the product and how risky it is. So that's why it's really important that we make sure that the system is working as expected, and there's a confidence that it will work in production as the user is expecting. For certain systems, verifying data quality may also be an objective. So it depends on the products, and maybe in few products, there need to be a lot of emphasis on the data quality, because test data is also one of the test activities which we covered, and time need to be spent on gathering the test data and make sure that we are covering different ranges of that. And so in few systems, it can be more important than the other ones. And of course, when we will cover later on the types of techniques, test techniques, then it will be more visible that how the data quality can impact the type of testing we are doing. Next is test basis. So what are the requirements, what inputs we need for testing? So over here, we will have system and software requirement specification, both functional and non-functional. So if we are testing a system, obviously we need some kind of requirements for that, and it can be in different format. It can be a document, it can be any project management system we are using, like Jira or TFS or whatever the company is using. So we need some kind of requirement specification, because we will design our test cases based on that, and that's how we will perform system testing. So we need this as test basis. Then another one can be risk analysis reports. So when we are doing the requirements analysis at that time and the test planning, we also come up with some risk analysis as well. And it can be in form of reports. It can be just part of a user story, etc., of specific requirement, because maybe few areas of the functionality are more risky than the other one. And it can be maybe from functionality perspective, that maybe one functionality was more complicated, and that's why it might be of high risk. Maybe from usage perspective, that this is a specific area where nothing can go wrong, like this will be very critical if it goes wrong, so that would be of high risk. Or maybe from legal perspective. So all that should be mentioned in the risk analysis report. Then use cases. So use cases, of course, that the journey, that what would be the flow of the journey, that will be mentioned here. Then epics and user stories. So all of you who are familiar with agile methodology and how Scrum works, you would be aware of epics and user stories terminologies as well. If not, then it's nothing but just like a high level, epics are just like high level folders. For example, in today's requirements, we mentioned my account and login. So login is a functionality, and under login, there can be different user stories. So login can be our epic. And then under that, we will have multiple user stories. And against that, then we will test those user stories, and we will come up with our test cases. So in that case, then all the main modules will be our epics, like my account, login, and maybe other modules as well. And this is how we can group our user stories. Because let's say this will, if we do it in this way, then we can make sure that yes, all the user stories in specific epic have been done, which means that that module is now complete. Next is models of system behavior. So now this model, it can be maybe description of the process and the activities that each component is involved in. Like if there is a component, my account, which we covered, where that component is being called in the entire system. So all, because that will help us to design our test cases and make sure that we are not missing any kind of behavior of the system. So that will be covered in models of system behavior. Then state diagrams. There might be state diagrams or flow charts, etc., which basically, in this case, state diagrams is given as an example. So it can be a visual representation. For example, if you have used Visio, in that the flow charts are built in Visio, and it basically shows the flow of how components interact with each other. So that can be given as a test basis for system testing as well. Then system and user manuals. So this can be in the case if we are building a product. So if we are building a product, then when we release that product to production, we need to also include a system or the user manual as well. So that can also be taken as the basis for system testing. Next is test objects. That what are the objects on which we can perform system testing? So few examples are applications. It can be a desktop application, it can be a web application on which we have to test as part of system testing. Next is hardware software system. So it can, if it's a hardware system, then yes, we need that. Or if it's a software system, we need that as well. So we need whatever the kind of system we are testing, we need that in our test environment in order to perform system testing. Same can be operating system as well. Maybe we have to test operating system itself, or maybe whatever application or hardware or software system we are testing, we might need a specific operating system or multiple operating systems. Maybe we have a requirement where we have to test on different operating systems. So yeah, that's required for system testing as well. Then system under test. So system under test is basically nothing else but the entire system which we have to test. So it can be anything. Maybe it is one of the software system as mentioned over here. So it's just like a separate, different terminology being used. So this is the system which we have to test. Then is system configuration and configuration data. So we have to test the configuration of the system which we are testing, which includes the data we need for configuration. Why we need to do that? That sometimes when we are doing system testing, we are doing it on a test environment. And then when we are moving it to production, sometimes a functionality fails, not because of its functionality, but because of the configuration, because configuration is different on each test environment. So if something was working on test environment and then fails on production environment, it might be that the configuration was not correct, or maybe the configuration was not even tested over there and we didn't test it on with different configuration data. in the test environment. So this is also very important based on different kind of projects we are testing. Then the next one is typical defects and failures. So now what kind of defects and failures can be found during system testing? So the first one mentioned over here is incorrect collections. So it can be that the calculations may be incorrect. So let's say if we have an online shopping application and we are just adding different products. So if one product is for £50 and the other one is for £20, and then when we are adding it to the shopping cart, over there the calculation of the total calculation is incorrect. So that can be one of the defects. Or maybe at the end, if there is any kind of offer or sale going on that site, and we have a discount voucher, then when we apply that discount, there is a calculation issue with that discount application. So these kind of calculations issues will come under this type of defect. Second one is incorrect or unexpected system functional or non-functional behavior. So this is the same as we discussed earlier, that for example, in our login functionality example, if we are not able to log in, then that's like a functional behavior, that if we are able to log in with only valid username or password, and we're not able to log in using invalid username or password, that's the functional behavior. And non-functional behavior is that how long it's taking to go to the next page, or maybe if it's it's timing out, etc. So that will be the non-functional behavior. Third one is incorrect control and or data flows within the system. Okay, so now there can be different state diagrams, there can be different flow diagrams based on what will happen based on, okay, let's take an example. If again we take an example of online shopping app, and there is an offer that if we shop for more than £50, then we get a discount of 10%. And if we shop for more than £100, then we are getting a discount of 20%. And in the data flow, of course, data flow in both scenarios would be different, but maybe at the end, the discounts are not applied as per the total amount of shopping being done. So that will be covered under this incorrect control and or data flows within the system. Next one is failure to properly and completely carry out end-to-end functional tasks. Okay, so let's say that we have done shopping and we have submitted our order. What happens usually after that? Yes, we get a thank you message on the screen, and then mostly we do get an email as well as a follow-up with all the order details, and it's kind of a receipt for us. But let's say that everything in the function on the shopping app, it's working perfectly fine functionality wise, but we don't receive an email, which is not affecting the functionality of the app because functionality is working. We are able to submit our order. But then as email is a crucial part as well as an end-to-end functional task. So that will be an example for this kind of defect. Next one is failure of the system to work properly in the system environments. So let's say that something is, as I said earlier as well, that something is working in the test environment, but the same thing you release to production and it crashes. Something is not working over there. It can be functional, it can be because of some data type, it can be the configuration changes or the structural changes, the architecture changes of the both environments. That's why test environment, wherever possible, should mimic production environment. It should be very close to the production environment so that we are confident that whatever we are testing, so system testing requires a lot of time. We are spending a lot of time, and it will be of no use if we just come to know that the moment we have deployed this tested thing to the production, it failed over there. So that's why test environments are required to be as close to the production environment so that it gives us confidence that it's working over there as well. The last one is failure of the system to work as described in system and user manuals. So sometimes if we test a product functionality wise, everything is okay, but maybe it's not working as expected as it was mentioned in a manual. So that's why if there is a user manual and it's a product, then we have to test it according to the manual as well. Because if something is conflicting, then there are two possibilities. One, that either it's a mistake in the user manual, the functionality built is correct, or the other one is that it's not built properly as per the manual. So that's why that needs to be tested as well. Otherwise, we can come up with some defects over there as well. Next, the last one we will cover is approaches and responsibilities. So we know that at component testing, it's mainly developers' job to do that kind of testing. Integration testing, we also covered that. Okay, that what we have like two levels, sub levels, and integration testing. The component one is done by developers, and the system one is done by testers. Over here, system testing is done by independent testers because they are unbiased. So this is something which we covered earlier, that the independent testers are not biased, and that's why they are the best people to perform system testing so that they can see it from a user perspective and come up with whatever the defects a system can have. Going forward, what approaches are used for system testing? So when we are coming up with the test approaches for system testing, then these are the few things which we should focus on while finalizing our testing approach. It should be the end-to-end behavior of the system as a whole, then functional and non-functional behavior of the system, and also the test techniques, that which test techniques we need to apply for this specific system. And test techniques in detail we will be covering in module 4, so I will not cover a lot for test techniques for now, but yes, will be a key feature of what kind of test approach we will be covering or we will be coming up. Okay, so that was all for system testing. Now let's take questions if there are any. Okay, Vineet has mentioned there are lots of calculation in financial projects. Yes, Vineet, you are absolutely right. There are lots of calculations in financial projects. And of course, if they are not done properly, then there can be quite serious impacts. Is there anything else you would like to mention or ask about system testing? Otherwise, then we can move on to the practice questions. Okay, so there is nothing else. We can move to the practice question then. Okay, the first one is, Which testing is concerned with behavior of whole product as per specified requirements? So go through the options and let me know that what do you think is the correct answer. Okay, Mira has said C, Denmark C, Sahana C, Madhuri C, Vineet C, Jagriti C. Okay, that's good. And C is the correct answer. So everyone has given me the correct answer. Himanshi C, Yuvi C. Okay, that's good. So everyone is quite clear on that, that system testing is the right answer, because that's where we are testing the entire product. Okay, second one, system testing only focus on functional behavior. Is it true or false? Okay, everyone has entered B, false, which is the correct answer. So system testing doesn't only focus on functional behavior, it also focus on the non-functional behavior as well. Okay, so that's good. Everyone has given the correct answers, which means that it's clear. The concept of system testing is clear. Is there anything else you would like to ask or mention about system testing? Yeah, Himanshi, you are correct. System testing covers both functional and non-functional aspects. Okay, Vineet is asking, can you tell me something about link coverage testing? Okay, so Vineet, so I don't know, we will cover it in detail in the type of test techniques, etc., and like types of testing, but I can let you know briefly about link coverage testing. So link is that, again, that based on the state diagrams or the flows of the components, how it's linking, what we are, if there is a link which directs a user to another page or maybe another field, etc. So that kind of testing is covered in link coverage. If you have a specific question, an example you would like me to explain, I can do in that terms as well. But as an overview of link coverage testing, that what it is. Like in the example which we covered today, the submit, like let's say if we have a forgot password link, then if we are clicking that link, then what should happen after that? Mostly, it should navigate to another page where the user is being asked about a username or their email address, so that an email, a recovery, a reset password email has been sent to them. So that will be an example of link coverage testing, but there can be like many links as well, because sometimes if you use any website, sometimes if there is a hyperlink and you click that link and then it's broken, which means that why it's broken, because in the system it's not specified that, okay, if someone click that link, then what will happen. So that these all things are covered in the link coverage testing, that whatever the links which are provided in the system. Sometimes it's in the text as well, which is like just linking it to another page, redirecting a user to another page. So all those needs to be tested as well. Yeah, Vinny, that's right. As I said, that some you have mentioned sometimes nothing happened when we click on link. Yes, this means that we have given a link, but there is nothing on the back end. We have to tell that, okay, what happens if we click that link? If nothing is no response, or like no behavior is specified on clicking, then of course it will not do anything. Sometimes it will be unresponsive, or sometimes it can maybe just navigate to an error page, etc. Or sometimes it's not doing anything. So we need to test all those kind of links as well. Anything else? Any other question? All right, okay, nothing else. All right, then, yeah, that was a short session. So earlier I was thinking of combining the acceptance testing as well, but then I thought it would be better if we do it as a separate test level and not mix it with system level, so that you understand system testing one in a good manner, and then in the next session we will cover acceptance testing. So in next session, acceptance testing, plus we will also cover the next part of the module as well. So the next session would be next week on Tuesday. After this session, as usual, I will upload the recording. I will let you know, and also the slides as well. And hopefully by tomorrow, I will also upload the questions as well. So thank you everyone who do all the questions and submit it very consistently. And please just continue doing so. And if there are any questions after the session as well, please ask either in the group or ask me individually as well. Now, we have covered quite a lot in this syllabus. So I think now you should also start coming up with some challenging questions as well. Like, for example, now you all have access to the syllabus of the course. And if not, then you can go to the ISTQB site and see the syllabus over there. And there are numerous practice questions on internet. So the part which we have already covered, if there are any challenging questions, then please post it in the group so that we all get some kind of more practice. And if something which is not clear to someone, then yes, we can have a discussion over there. So yeah, I would expect that you start doing as well and do that as well, so that we can involve as many people in the group as we can. So I hope you enjoyed today's session. So I'll speak to you next week, and till then, do take care of yourself, and I'll see you later then. Bye.